Okay, so today we're going to talk about this question. So if you have a hole in the inner membrane of mitochondria, how will this affect oxidative phosphorylation? So oxidative phosphorylation is basically talking about we're oxidizing NADH, which is our electron source, and we're using that electrons to drive phosphorylation, which is ATP formation. So what's going to happen if we have a hole in our inner membrane? So we can think about two different things. The first one is electron flow, and second one is pH gradient. So electron flow is something that is very exergonic. So after NADH drops off its electrons, the dropped off electrons are gonna go from low reduction potential to high reduction potential. And as they do that, and eventually it's gonna reduce the oxygen, that requires no energy. But pH gradient, the reason that we get pH gradient is that we get proton dumping, and we get proton dumping from electron flow. So proton dumping, or pH gradient, is dependent on electron flow, whereas electron flow, since it's exergonic and it's going to happen by itself, that is not dependent on proton dumping. So let's say that we have a hole, and that is indicating that we are actually destroying pH gradient, because if we have a hole in our inner membrane, that is telling us that as we're dumping our protons, those dumped protons are actually going to come back into matrix, because there's a huge difference in concentration of protons in intermembrane space and matrix. So if we destroy pH gradient, that is telling us that electron flow will still flow, but ATP formation will actually not form. So ATP will not actually be formed if we destroy pH gradient. And to answer this question, we can just simply say electron flow is still going to go, but since pH gradient is destroyed, there will be no ATP formation. And that is how you answer this question.